sometimes in your application problems and even in the information they give you just for, a regular problem where they give you the figure and you're just trying to find the surface area or the volume with limited information, sometimes you have to go find some of that information. Most of the time, the Pythagorean theorem is going to be involved with that, or some other formula that you've used in geometry before, like say the area of a triangle. So problem number like 3B, 3B has an area. You'll notice they've shaded it in. They're trying to set you up on understanding to be able to find the volume of that. Well, first you're going to have to find the area of that base triangle. Let's deal with one that's a pyramid that is looking for surface area, because I would assume that if you are able to find the surface area of a given pyramid, you would also be able to find the volume, because the parts needed to be able to find those things are within each of those formulas. So let's say this. Let's say I have to find the surface area of this thing. To find the surface area, and if you go to, again, reference your pages that you've been given here, page 473, at the top it says this: the surface area for a pyramid. It's the sum of all the faces. So x squared plus 2x for a square-based pyramid, where x is the length of the sides of the square base and L is the slant height. So if we know the length of, say, this pyramid base is 4 centimeters, and we know that and you can't see it very well because of how I've drawn this, but your height, we'll just put it off the side here, that's going to be in the middle right there. So we know that and I'll just label it as height is, say, 10 centimeters. Think about what it is I have left to be able to find. So if they don't come right out and tell you what the slant height is, you're going to have to draw this right triangle in your figure to indicate to yourself, hey, I need to find that value of L. A lot of times they give it to you, but I'm giving you this harder version so that, when you come up to that, you have something to refer back to. It's a little more difficult to find. Guys, if this is a square pyramid, we know this, say, is 4 centimeters. You can find that length right there. It's halfway across. So you know that this has to be 2 centimeters. In this, and you should see, there's actually a right triangle sitting inside of this figure. So I'm going to try to shade it in a little bit. There's that right triangle sitting inside of there. We know this is 2. We know the height. Also, that's that side length of that imaginary right triangle in there. And now I got to find my slant height. Hey, Pythagorean theorem. So we know this. I'm just going to cut right to the chase here. You can go look this up if you're not sure how I'm getting this. If you think about it, a little bit of your past work, the length of that slant height is going to be that 10 squared plus 4 squared. And you got to take the square root of that. So in other words, the square root of 116. All right. So if you do that calculation, let's do an approximation of that. That's about 10.8. So we're going to record the L. We're going to go with 10.8 because it's 10.77 on my calculator. Should be as well on yours. All right, so now we have all the information we need to be able to find the surface area. So think about it. I'm going to take the square base. So I'm going to add the area of the base. I'm going to call that big B. They don't do that in the text. They just say, if it's a square base, you're going to go x squared, or 4 squared in this case. But it's going to be the area of the base plus all the faces of that pyramid. And they're calling that 2xl, or 2 times that x value times L. So let's think about this. Why would it be 2XL? Well, the side of this is a triangle. If I know my slant height and I take half the base of that, it's a triangle, right? So I take half of 4, that's 2. So the area of one side of my pyramid, that triangle, is going to be that L, which is the height of that triangle. It's also the slant height of the whole pyramid, but you got to look at it in pieces. So that's going to be that slant height. We take that triangle area is found by taking 1/2 times our L length times our base length. Well, I'm just going to go ahead and put 4 in there. We know this is what, 10.8. So 1/2, 10.8 times 4. How is it that that then is going to convert into 2XL? So think about this. How many of these triangles do I have on my pyramid? They're all the same because my base is square. So I have 4 of those. So really I have 4 times this 1/2 10.8 times 4. Well, if you do that math, you're going to go 4 times 1/2 times 4. Well, think about it. The 4 times this first 1/2 right here. So if you go 4 times that 1/2, you're actually going to get, what is that? 2 times 10.8. There's my slant height times 4. Guys, the 2 and the 4 here represent the 2 and the x up here. So you can trust that formula. I did all of that math right there to prove to you that 2XL gets the job done. I don't want you to just to like mindlessly use a formula without knowing how did those parts, how did that show up? Why is it 2XL? Again, if you follow what I just did there, I'm proving why 2XL works. All right, so what is the surface area? Let's cut to the chase here now. We're going to go 4 squared because the base lengths are 4. There's the area of that square plus 2 times that 4 times that 10.8 that we found, which is, you calculate that all out, you can type it into your calculator just like that. I get about 102.4, and this is centimeters, so that would be centimeters squared. That is all the area, that's the surface area, all 4 triangles of that pyramid, and then also the base all together. All right, let me double check my calculation here. I typed in 4 squared times 2 times the base length, which was 4 times 10.8, and I got 102.4. Hopefully there's no mistakes in that. I think that's pretty good. If you wanted to find the volume of this now, let's just show that real quick. So to find the volume with this same figure, I'm going to go, the volume is equal to 1/3. And this is actually on that same page, 473. You're going to go 1/3 the area of the base. Well, we know that in this case, that is 4 squared still. So the area of the base times the height. Now, this is not the slant height, guys. This is the height. So we were given that the height there was 10. There's the plug-in. I'm going to let you check that for yourself. There's no check back on that, by the way. This one's not in the text or anything like that. This was an additional example for you to be able to use and then go do the homework. But if you type that into your calculator, you should get a value. And remember, volume is units cubed. It's the number of cubes you could stack up, go inside of that. Of course, there would be pieces in there, but we're not worried about that. All right. Hopefully this helps you. I'll see you guys in our office hours and our Google Meet. Be sure to ask questions about that. If you have questions, hopefully you've had a good geometry background and this is just review for you. All right. Have fun.